Hello friends, welcome back. Now let us see how an element can be inserted into any given array. As an example, we have an array which is shown here, having elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And at position 5, we would like to insert a new element having a value 50, and after inserting, the array will look something like this: 1 2 3 4, and this 5 gets displaced to the position of 6, 6 gets displaced to 7, 7 gets displaced to 8, and so on, making a free space wherein the 50 gets inserted. So the overall process is, so first step is this 10 has to be moved one step to the right, then 9 should be shifted to this gap, 8 should be shifted to the next created gap, then 7, then 6, then 5. After 5 is shifted, a gap is created here in which 50 can be written. So to do this, we need to keep shifting from the tail end one step each, and therefore in all, in the worst case, we may want to insert at the first place, then all n elements need to be shifted, and hence the time complexity of this action is order of n. So how exactly this happens? There's an example we can see. We wanted to insert a 4. So to insert a 4, say at this position, then what we need to do is 10 is shifted to the right and a space is created here. 7 is shifted to the right and then a space is created here. The 6 is shifted to the right, then a space is created here, and here a number 4 is written. So we need to shift one by one from the end, and that's what is required to do. And hence it's going to be, worst case is inserting in the beginning of the array, and the best case is inserting at the end. That means it's just as simple as appending. It may take a constant time for that, order of 1, but worst case it will be order of n. So that's a simple code we can make use of. So let me just use this code. So here we have an function used, insert, wherein we are giving an array and the number which we want to, the size of the array, and where we want to insert its position, and the value what we want to insert. So we start from the end and keep shifting the one element to the next position. So whatever was there in I minus 1 position is shifted to the ith position, and we are beginning I from the value n and going down till we reach that position. So till that position we shift from the end and keep that position blank, and there in that position in the array we insert the value, and then each time we just increment the size of the array. N is the size of the array. So in the main example we can see we have created an array of size 7, but we have inserted 5 elements: 10, 20, 30, 40 and 50. And at position 3 we would like to insert 25, and then we see, just to print these numbers before insertion. So it should print 10, 20, 30, 40 and 50, and then we insert into this array. The size of the array given is 5 currently, and the position is where we want to insert. So we want to insert in the third place, and what we want to insert, the value that is 25 we want to insert. So we call this function, and then to show that we get the correct answers, we again print and show that. So let's just run this and see what we get. So before the insertion, we said it was 10, 20, 30, 40, and 50. And we said that at position 3, that means our C code starts the counting from 0. Therefore, the 0 location is 10, 1 location is 20, 2 location is 30, and 4 location is 3 location is 40. At 3 location, 25 is inserted. So this 50 is shifted once, then 40 is shifted once, and a blank space is created where we insert 25. So that's the action we take for working. So we can just do same thing. Say I can just change this to 1. That means the second location it is going to shift, and the new value is inserted into second location, as you can see here. Now 25 gets inserted into the second location because we have said the position as 1. 1 means this is 0 position, this is 1 position. So from 1 position everything was shifted to the right once, and then a position 1 is created a blank wherein 25 is written. So that's what the insertion process is. It's of order of n. Thank you.